Hi everyone, Miss Andronicus here, and today we're looking at simultaneous equations, part 1. Okay, so with algebraic equations with more than one variable, there can sometimes be many options that could satisfy the equation. Okay, so for example, you've got 2x plus y equals 10. So two variables here, therefore you can only propose answers that satisfy. So here are 3 examples of answers for x and answers for y that would satisfy that equation. Here's another one, okay? You've got 3x plus y equals 16 and a lot of options, by no means the whole list of options. So which one is it? Which one is it for this answer and the one above? To do that, you solve them simultaneously. Okay, so simultaneous equations, when you solve a pair of simultaneous equations, you need to find one pair of values for x and y that satisfy both of them at the same time. Okay, so let's give that a go. All right, so have a look at those same equations here. If we put them together, the first thing we want to do is focus on one variable at a time, having a look at that hint, okay? The goal is to cancel one algebraic term out in order to solve for the other. So if I look at the x and look at the y, the idea is the first step I want to do is I want to think about adding or subtracting these together vertically. Okay, the goal to do that is to cancel. The goal of doing that is to cancel. So for example, if I take 2x and 3x in those equations, if I add 2x to 3x, that's going to be 5x. If I subtract, that's still going to leave me with an x. The goal, remember, is to cancel it out, okay? So when I bring them together vertically, that's not going to help me. If I look at y, though, there's only one of each. That I can work with. If I take the first equation and subtract the second equation, then I know that I'm going to cancel out that y, because that's essentially like saying y subtract a positive y, well, that's just going to be 0, okay? So because of that, this is what we want to do. So I'm going to think vertically. I'm going to say 2x subtract 3x is going to leave me with a negative x. The y's cancel out, and 10 subtract 16 is a negative 6. Now, for solving any linear equations, all those rules still apply here. I can't be left with a negative x. I need to divide by negative 1, because remember the coefficient is technically 1. Divide by negative 1 on both sides to get rid of that negative, and x just equals 6. Okay, so the next step from here, now that I've got one of these terms solved, okay, one of them is solved, great. The next step is to substitute into one of these equations. So if I take that first one, 2x plus y equals 10, I'm going to take that 6 that I have now for x, and I'm going to put it into that position. So 2 times 6 plus y equals 10. 12 plus y equals 10. Okay, again, using my rules here. So we go subtract 12, do the same on both sides, y equals negative 2. Okay, the y itself is on its own without a negative next to it, that's fine. It's okay, it equals negative 2, not a problem. Now, I have an answer for x, I have an answer for y. Brilliant. The last thing I must do when I come to simultaneous equations is I have to do a check. So I have to check at the end. It's really important. What that means is taking both of those values. I like to sometimes put it into the one equation that I haven't used, one of the original equations that I haven't used. Okay. equals that. So if I go and substitute all my values in, 3 times 6 plus negative 2 equals 16. I need to make sure that this is true. So 3 times 6 is 18 plus negative 2 equals 16. Well, the positive is cancelled out, so it's 18 take 2 is 16 equals 16. Yes, I'm correct. If I don't do that check, then yes, it is possible to come up with answers that are incorrect for X and Y, so you have to go back and do the check. If I go and have a look at my options up here, you may have already noticed that I actually did manage to come up with them there, okay? So here are your notes or your steps for solving simultaneous equations. Choose which variable that is the easiest to cancel. Add or subtract the equations to cancel it, so you want it to equal 0. And I'm just going to draw your attention to this example. Here, you've got a negative x and an x. You can't subtract a negative x and an x because that's going to be negative 2x. So in this example, you would have to add them together because it would be negative x plus x. It's like saying negative 5 plus 5, that's always going to equal 0, so that would cancel it out. Brilliant. Okay, so that's an example of when you add or subtract, and that's where adding comes in. Number 3, solve for one of the variables, substitute the answer back into one of the original equations, and solve for the other variable. Do a final check. Okay, we did all of those in the question above. You must do a final check. Give them a go. They take a little bit of practice, but if you approach them like this every time, you'll get them right. Good luck. Thanks, guys.